Good morning. Thank you for all you for coming. Today I'll be speaking about how we at Wehkamp, with a small team of 3 data engineers, saw the problems happening in our platform, our data platform that we had at Wehkamp, and took on a challenge to build a lakehouse to try to solve these issues. I hope that our experience can help you, or at least inspire you to solve your own problems. First, a little bit about myself. I'm both Portuguese and Dutch. I've moved to the Netherlands 4.5 years ago. I am a korfball player, which isn't a very well-known sport worldwide, but if you want to know more about it, just hit me up. Besides that, I like to follow the NBA, and most recently during the pandemic, I've discovered my passion for golf. It was the only sport that you could actually do without being illegal. And at Wehkamp in the Netherlands, I work as a data engineer for Wehkamp, which is one of the biggest online retailers in the country. And today I brought some numbers for you so that you can have some context on what kind of numbers are we talking about. So we sell more than 300,000 products across 2,500 brands. We ship 11 million packages per year to our customers, and we have daily more than 600,000 visitors on our website and app. So we're not talking about Amazon scale or anything, but it's not a startup. Wehkamp as a company has existed for 70 years, not as an online retailer, of course, but the retail model has existed already for 70 years and is at a very, very loyal customer base. So this is the agenda. We're going to start where we started. What was the platform that we had a few years ago and how it evolved towards our goal architecture. Then we're going to see how we actually implemented it, how it looks today. And then we're going to dive a little bit deeper into 3 of the components that make this platform, this architecture work. First, our custom-built framework that we call Vint Ingest. Then how we are solving the pseudonymization. If we're going to go for the democratization of data across the entire company, this needed to be solved. And then we'll look at how we're managing incidents through Slack. So where did we start? We started in a traditional BI environment with data warehouses, just a common architecture. You have data sources, some ETLing, filling in the data warehouse. It's fully on-premise with all the restrictions that come attached to that. It did work quite well. It was battle tested. Single source of truth, but it was limited, like I mentioned, by being on-premise, and it was limited to structured data. And with the move to the cloud and the big data becoming a thing, cheap object storage and all that, a lot of use cases come up, not just in terms of having to use unstructured data or semi-structured data, but also the streaming side of it, which wasn't possible in the old world. And this is when Databricks was introduced in the company to solve and enable these use cases. And it was introduced as a self-service platform. So the analysts that were using the ETL tools on the previous world, now they were using Databricks. And they were not just those analysts, actually everybody within the company was incentivized to just pick up Databricks, learn it, and try to create business value out of it, out of all the data that we had. But fairly soon, the analysts realized, oh, yeah, you know, that data that we had before, we also want that in the new world. We want to use the power of distributed computing where we have a Databricks, all the fancy new tools. We want to use the data that we had before, because the core business of the company didn't change. So we've made some pipelines to get that to work. And then other analysts said, oh, yeah, that's very nice that we have that, but we are more ambitious. We would like to have the data earlier in the morning. So we've made some shortcuts to make sure that the data was available for those notebooks, for those pipelines of those engineers, those analysts. And indeed, the speed went up. Quality is questionable, and the stability definitely went down. And you get the point, right? So as Databricks got more established within the company, the more pipelines, the more sources, the more teams started to use, complexity only grew. And now, don't get me wrong, having all those teams, not depending on one central core engineering team to create value out of the data, that's awesome. But it came with a collateral damage. That was a maze of notebooks, not applying the best practices of engineering. So we needed to find a way to still benefit from all that eagerness from all those teams to create value out of the data, but steer them in the correct direction and help them with best practices. Which takes us to our goal architecture, just a simplified architecture, sources, and then the lakehouse in between, and then fit it to let those users not only use Databricks on top of it, but also the reporting and analytics tools that we had. But believe me when I tell you that I would love to be here today and telling you this is how it looks like. But if I'm being honest, it looks more like this. We know we are realistic. We know that it's not a one-day migration thing. We've built it on the side. And organically, as the lakehouse will mature, the word will spread across the company, across the organization, and people will start to migrate their pipelines to the lakehouse, to the new architecture. And since this new world is where the good data is, and it comes with a lot of free perks, and people love free stuff, so we believe it will just happen eventually. So today I'll be speaking about what we've done on the side, and what we believe is good enough that will convince everybody to stop doing what they were doing and move towards the lakehouse. And the lakehouse, I'm not saying anything new here. So the lakehouse, there wasn't really an option for us. Or there was options, but there was only one real option for us. We already had Databricks. We already knew how to use the Delta Lake. We had a lot of Delta tables already, just not structured in a governed way. So having a lakehouse was the obvious way. And essentially the lakehouse, like you've heard a lot during this conference, it sets out to solve exactly the problem that we had, a hybrid platform where we had the data warehouses and the data lake, wants to unify it into one platform, into one architecture, and take the key benefits of both and serve all use cases that we have for data. So let's take a look at the requirements that we had identified to design a platform that would solve this, that we would feel comfortable with. And we came up with these. So first of all, we needed a storage layer that would provide asset properties. That was the Delta Lake. We already knew how to use it. That was an easy choice. Then we said we want as much incremental ingestion as possible, but not just the ingestion, but the processing of the different levels of curation. And at Wehkamp in architecture, we use the medallion architecture, which uses bronze, silver, gold to identify the different levels of curation. Then the pseudonymization. We needed to find a way to hide the data away from those users, because we really want them to use it, but they are usually not concerned about anything around the data. They are very goal directed, so they just want data, and we want to provide it like that, because more than 90% of the use cases, you don't need personal data to do what you want to do. Then column naming standards, that's a big one. We really wanted to have standards so that using those tables became a nice experience. You don't need to rename and find out what was what, just they would match with each other. And like I mentioned, we wanted to have best practices, find a way to build into our way of working a best practice to help those teams apply the best practices. And this is what we've come up with. There's essentially 4 blocks in this architecture. There's the data sources, then the ingestion to the Delta Lake, which is contained within the gray box. And then we have the consumption of the data. On the left, the data sources. At Wehkamp, we have the strict rule that the product teams are responsible for pushing the data to the rest of the organization. Nobody will be querying the production databases, so it's really a push system and not a pull system. And we are using mainly two ways to get this integration done, through Kafka and S3. Kafka, since it is our backbone of our microservice architecture, and S3 for any non-streaming use cases, or when the application doesn't know how to speak to Kafka. And in those situations, we can even use the autoloader to transform batches into streams. So that was also covered there. Then we have the ingestion of the data. Vint Ingest is where the pseudonymization is handled, but I'll go into more detail there later on. So when ingesting, we are extracting the original values, hashing them, and storing them in a separate layer that we call the PII vault. And to this vault, only a select group of users have access because they require access to personal data to fulfill their role within the company. So after this step was done, then we can simply ingest the data pseudonymized into bronze. And bronze is then the first level of the 3 levels of curation that we have. In bronze, we have the raw ingestion in history, and raw should be taken with an asterisk because we are in place transforming the data so that it is pseudonymized. Then process to silver. Silver is where we apply the definitions and we create our data features. And then gold, it's really fit for purpose. If we take a closer look to this green box, I hope it's green. This is how it looks like on a more detailed level. Bronze, we've set it up one database. It's a one-to-one map to each one of the sources that we are ingesting, purely for governance purposes. Then in silver, we've decided we have one database, and we have a strict rule here that we don't mix and match data coming from different data sources. We've had problems in the past where there was misinterpretation of the data. So this is while in bronze you have governance concerns, here we really wanted to have lineage concerns. We had problems in the past, and I can give an example. At Wehkamp, orders is managed by different systems. One is leading when it comes to sales, the other one is leading when it comes to customer demand. And we've had problems in the past with misinterpreting where that data comes from and what are orders and which system that data came from. So in silver, really was important for us to have this lineage well declared. And then if you want to have an overview over the order concept, the order domain, then you do it in gold, in what we call in a database that we call the unified model. In this unified model, you have not just for orders, we can think all the core domains like customers, returns, web sessions, order lines, if you go one level deeper on the orders. So this unified model is then the place for everybody in the company to go, and the unified model database is the first place where they can go if they want to find data and be sure that somebody is taking a look at it and making sure that it is good quality. So our gold layer consists of one database that we call the unified model, and then different databases per purpose. But let's go back a bit and take a look at Vint Ingest. How does that look like? Because it is a crucial component in our architecture in more than one way. It essentially is a Python library that was built that consists of modular code. PySpark code. There's no magic in there. They're just objects, classes, that through settings in a configuration file, in a JSON file, you can steer how you want your code, your ingestion to happen. And so it is very powerful because you can allow the users that know how the data looks like through a few settings and through version source control and pull requests and all that, you can create new data feeds coming in. And all the rest is handled by the modular code that we've already written before. Then we have the pseudonymization. This is where it's happening. I'll go a little bit deeper later. And then as a design choice, we've said we just want to use the streaming API in production. Let's just do that. Vint Ingest can use batch for development purposes or for previewing or stuff like that. But in production, we said, let's just use the streaming API. For batch use cases, we use trigger once. So we really use all the power from the streaming API to manage the checkpoints and process data and ingest data as much as possible in an incremental fashion. If we take a closer look, each ingestion is defined by two sources, two sets of configurations. The read options, so those options that you would pass to the data frame reader. Stuff like, do I want to use notifications or not when you're using the autoloader? Do I want to read from beginning when you read from Kafka? So all those settings you would pass to in this read option config file. And then you have the data, another configuration file specific for the data where you pass the schema and write options like, do I want to append or override? Which columns do I want to partition by? So we have these two sets of configurations. If we look at how it's running, we have different jobs that are running at a different frequency. And all of these jobs execute the exact same version of the wheel, of the framework. And through a parameter, it identifies which configuration files it's supposed to run. So the first step in those jobs is loading in those configuration files that belong to that specific job. And then through a sparse scheduler pool, we are submitting all those different streams to the cluster that belongs to that job to execute them in parallel. And we can, with another parameter, we can steer how much parallel do we want this to be. So we can control the resources of the cluster like that. Let's take a look at how we would do this. So in this example, we have a feed of JSON files coming into our awesome bucket, and we want to ingest it into our bronze database, in our bronze layer. We want to use autoloader for this, so then we pass a bunch of options that are required for the autoloader to work and how we want the autoloader to work. And then another file called uwishlist.json, where we have a whole bunch of settings. We see the target table, target database, what is the connection that belongs to this configuration file that we just defined before, the frequency in which we want this configuration to file, which is going to be picked up by the job with the parameter. And then if we go a little bit lower to the schema, this is where we're passing the schema as well. And you can see the first field is a customer name, customer number, sorry. And we pass it here that this customer number is a PII field. It contains personal information. So here is where we really rely on the users, the people that know what the data looks like. They are the ones responsible for indicating which fields should be pseudonymized. And this is how it looks like. We do an in-place transformation. So after extracting it and saving it in the vault, the table will look like this. So this is the pseudonym of the customer number. We do it in place. In this case, it's a very simple example. It's just a flat schema. So with a with column, you can do it very simply. But we have also added support for nested schemas. So with a recursive function, high order functions, we are solving it like that. This, you might have noticed, we use an explicit schema. This, of course, means that schema evolution is a thing. But the owners of those configuration files, the owners of those feeds, are responsible for updating those configuration files if the schema ever evolves. So that's given to the power to those users still. And if the schema does evolve So a new field is added, it won't fail. It will simply ignore that field. If there's a backward non-compatible change, then Delta will simply say, I don't know what to do with this, please fix it. So it will never corrupt the data. Let's take a look at how the algorithm and how we are solving the pseudonymization. We are using a one-way cryptographic hashing and then salting it. And besides salting it, we are adding to the string as well the PII type, which there before was the customer number. We use this concept of PII type because we understand that not all personal information is the same. So we wanted to find a way to distinguish between these different types of personal information. I can also give you an example. For internal market research, you don't necessarily need to know what an email of the customer is. But for marketing execution, if you really want to send an email to the customer, then of course you need to know what the email is, and you're not interested in having the hash. So having this concept of different PII types built into how we're hashing, really allows us to separate these concerns. And then after hashing it, we are re-encoding the data to make it more efficient. You can really save like 40% of your storage, so you should have a look at that. Okay, it's very nice that the algorithm, how we are creating those hashes, but how do we have all these different jobs? How do we manage to save all this mapping into one place that can be usable? And if you want to for those users that are allowed to access the PII vault, how do we get the data in the PII vault so that those users can use it? Each job, like I mentioned, runs the same code. And the first step, inside the streaming, we use a for each batch. And the first step is we're going to look at the data, extract the original value, hashing it, and this mapping is written to one delta table that we call the PII queue. So essentially, we use a delta table as a queue. And since all those jobs are writing in an append fashion, it will never give concurrency issues, so that we leverage the Delta concurrency protocol for that. And then on top of that, we have another stream, that reads all those changes and does a merge to our lookup table. And that's how we end up with the lookup table for whoever wants, or not whoever wants, whoever can. So those select users that can access the PII lookup table, then they have the data if they ever need to recover the original values. Alerting, the last component that I mentioned in our agenda, that we have in our agenda, how we're managing the incidents. It's nice to tell. At Wehkamp, Slack is really a core component of our incident management process. Slack is where the engineers are. Nowadays, not just the engineers, everybody within the company, from higher to lower management, is using Slack. And we have a really streamlined way of handling the incidents. If there is an incident, we create a short-lived channel. We bring everybody that can help, wants to help, just wants to know what the progress is. We bring them all to there, and all the discussions, all the hypotheses on how to solve that problem, we do it in there, which helps because then you have immediately documentation. If later on you see, okay, that happened, I know that happened 2 months ago or 2 years ago, we can always go back to that channel and see how that person solved it. So we really wanted to chip into how we're doing this to the rest of the organization. We want to bring it to the data side as well. So we've found a way to stream our alerts to Slack, because having the alert in Slack already means that you can simply refer to that message and bring it to the incident channel, and everybody has the same view of what the problem is. So that's really nice to have. So it solves that communication problem. So in our data platform, we have two types of alerts. The runtime alerts, simply if your job fails, your execution failures. And here, because we have that Spark pool, we're not interested in knowing job A failed. We want to know which feeds failed, because Databricks will just tell you, oh, the job failed. But we have 50 streams running in the same job. So it can be that 49 of them succeeded and one of them failed. So we want to have that granularity in our alerts. And then we have quality alerts that we are using DQ for. Just a bunch of static rules that we have right now. Of course, it can be improved, but for now it is working for us. How it is working, we have a Slack webhook that we use that has permissions to write to Slack, just a Slack bot. And we are managing the Slack token with Databricks secrets. When the job starts, it loads those secrets, and then it can use that token to steer the message. And like I mentioned, we really wanted to have it on table level or feed level or stream level and not on job level. This is how it did look like. Not would like, this is how it is. This morning I got an alert that looks like this. This is how it looks, and I don't know if you noticed the format. This is on your phone. This is how you'd get it on your phone. So you have an hyperlink to the job. You have an hyperlink to the run ID. You can immediately click and go there if you really want to go to the job run. It tells you which table it failed. And as a bonus, in the thread, we submit a file with a stack trace. So if you really want to know whether you should act on it, you should create an incident channel, or it will just auto-recover. So you have immediately, at the glance of your phone, you can immediately see what went wrong with more detail than just job A failed. What am I supposed to do with that? So that's all I had for the components. Of course, I want to take some time to look back at our journey. We started with a traditional BI. The journey has been long. We're moving towards the right direction. We had growing pains, of course, but we really believe we are moving in the right direction. Right now we have 100+ streams that we are managing with little to no downtime, which is really awesome since we have such a small team of 3 engineers. The adoption we see that is steadily increasing. We see more and more people are coming to us just with questions. Oh, how can I do that? Can I also do that? And I really believe we found a good foundation. We're moving in the correct direction to help the business with a good platform for the new use cases. Because also see the business is realizing all the things that other companies are doing, and they want also to do it. So it's the requests just keep piling up. Oh, forgot to mention that. That's a nice use case. It's nice to mention. This Smurl, this sticker that we have a bunch of them spread out throughout the office. This one contains customer demand. It's a funny story because the board saw this, and these had more up-to-date numbers than the official dashboards that they were using. So they were like, okay, how is it possible that our official numbers are slower than those numbers that we see on the wall? So that was quite a win for us in our LakeHouse journey, that the board managed to see it like that, just without us announcing it. So that was cool to see. Like I mentioned, it is a journey. It isn't over. We need to keep iterating. There's always new things to do. The migration isn't over. We really need to keep maturing and filling our lakehouse with all the data that we had before, so that we can really move away from our old platform. Iterating on the platform itself, because there's always new things, new requirements, so it really needs to keep supporting that. Then, next to the migration, there's, like I mentioned, the business really wants things we are We can multiply, so really hard part of it. But there's a new project that is to support multi-label. So we had Wehkamp.nl, and now we need to start supporting different labels. That might mean that we have different lake houses next to each other, and then share data through delta sharing. So that's also something that we need to work on. That's also the next step. Nice, of course, I'm complaining, but it's all technically, it's really exciting to be able to do all that because the tools exist. It's just pressure from everywhere. And then we are new kids to the Databricks E2 party. We are all early adopters of Databricks. So we've had some struggles with migrating from our previous single tenant workspace to the Databricks E2. It is still happening, but I'm glad to say that we can start using E2 now and all the new fancy tools. Some of them were just announced this past 2 days. Really excited to use this and integrate those into our LakeHouse toolkit. And that's all I had for today. Thank you very much.
Excellent. We have a few minutes for a couple questions if anyone want to maybe raise their hand or... Oh, yeah.
Hey, you mentioned regarding the 3 layers model, you're using different data stores or database, especially in the silver one. Can you please elaborate what exactly database is that?
Did you understand? I didn't understand very well.
I'm asking, hope I'm not asking too loud. What is the data store mentioned in the silver layer, in the 3-layer architecture?
Everything is S3. So Delta is just a format, but in essence, underlying Delta isn't living anywhere else than S3. It's just all those databases that you see are Hive databases. They're just metadata. But the real files are, everything is on S3. That's why when I put there the Delta symbol, I put /S3, because in fact, Delta Lake is not an object store, it's a format. But if you're really looking detailed, it's not even a format, just a way of managing metadata because the files are Parquet.
Got it. Thanks.
Yeah, probably have time for maybe one more question here. Over. Yes, thank you.
I want to know, like, after you migrated to Delta Lake and LakeHouse Architecture, did you see any improvement in cost in compute?
It goes, we haven't seen improvement in costs dramatically yet, because we are running both at the same time. So once all those pipelines, right now, so we see all that data that's being ingested and processed on those maze of notebooks, are bringing it into our lakehouse, but that means we are having it both at the same time. And then we are providing an alternative so that those pipelines can stop being used, can shut off the jobs. Okay. And the data that they were creating simply exists in a different pipeline, but with better support, better tools, just a more mature environment.
Yeah, we might actually have time for one more quick question, if anyone else wants. Yeah.
How long was your journey to?
Since the beginning?
Yeah, since the beginning, since you decided.
The traditional BI, that was before I joined. I'm 28, so that was I think it started in 2000, the early 2000s. Databricks was introduced in the company 5 years ago.
Okay.
So that's the more, I met the company 4.5 years ago. That was really just before I joined. So that's what I can relate the most.
Is there anything that you would recommend to increase the pace of that,
of the migration?
Of the migration?
That's a good question. I think it's an organizational thing. From our side, all we can do as an engineering team is remove roadblocks. So if you say, okay, please migrate, the first thing they say, migrate to what? So our first step was create an option. And then you come to the organizational side, because you do need those teams to have time to work on the migration. Because those, we want them to migrate, but then there's a case to be made, there's a business case to be made, okay, how much time should I give, or should those leaders, should those management give those teams to work on the migration? Because they need to create new features themselves. So how much value is in those new features compared to reducing costs or reducing downtime or increasing the amount of time that those teams can use on the new features? Because if they don't need to maintain all those failures and all that instability, then eventually they will have more time. But it's the selling of this situation to management that's the biggest issue. If management understands, usually goes fast, but they need to care. So that's the biggest issue.
Excellent. Yeah, thank you so much for the really great presentation, for the questions. Maybe one more round of applause for good measure.